Okay, in this video, we will solve two logarithmic equations. This is the first question, and our second question will be this. So let's get started. And we know that log by itself is actually log 10x is equal to 5. If we're not given the base of a number like here, then it's assumed that the base is 10. And so this is what we could say. Log base 10x is equal to 5. And using one of our log properties, if we put a 10 here, we'll also put a 10 here. And by doing that, let me pull up the log property. We get something like this. So a log ax is equal to x. And so for our case, this right here would be 1, and we would be left off with x. So x is equal to 10 raised to 5. And this is our final answer, and that's all we need to do for this problem. And now we will do the second problem. And so for this question, using one of our log properties, what we could say here is that if we put everything here 3, 3, 3, just to cancel out the log term, we would get 3 squared, because we have a 2 here, plus log 3 parentheses 2x, this term right here, is equal to 3 log 3 parentheses x plus 5. And in the last video, we know that 3 log 3, if it's the same number, it's essentially 1. And so we would get, so 3 squared is 9 times 2x is equal to x plus 5 is equal to this. And so this is 18x. So 18x is equal to x plus 5. So we could say 18x minus x is given us 17x is equal to 5. And so x is equal to 5 over 17. And we simply need to box in this answer. But we're not done yet. What we need to do next is plug in x is equal to 5 over 17 to make sure it's an actual answer. So when we plug in 5 over 17, we get a number greater than 0. We plug in 5 over 17, we also get a number greater than 0. So this is an actual answer. However, if, for example, x was, say, negative 7, we plug in negative 7, we would get negative 2. And we can't have a log value of less than 0. It has to be greater than 0. And so for that case, we would say no solution. But for 5 over 17, both cases, we get a number greater than 0, and so it's allowed.